Okay, we'll go ahead and get started. If you haven't noticed already, I have posted last year's midterm exam up on CCLE. Okay, and I'm sorry, I've been dragging my feet, or just kind of it's been taking me a while. I'll have a homework posted as well that covers pandas. It will be due after the midterm. Okay, but it's probably going to be good practice to get used to working with pandas. And so, I met with a lot of you guys. Almost everyone. There's a couple groups left. Okay, and I know during kind of the while we're talking about your data, I noticed that a lot of you are currently using R and Excel to explore the data, and nobody has really used Python to explore the data. Okay. Now remember, you guys are taking this class because you want to learn Python, and yes, it's absolutely true that when you use Python, like, you are way slower using Python than you are using R. You're familiar with R, like you've had a whole bunch of courses, and so now you're comfortable using R and manipulating things and using dplyr and summarizing things with R, okay? But you signed up for this class because you wanted to learn Python, and so I strongly, strongly, strongly urge you to force yourself to use like Python and only Python, like from tonight until next week. Okay, you have to get comfortable with pandas. Otherwise, when that midterm comes, 1 week from today, you're going to be in trouble. Okay, you're going to run out of time. All right, and it's probably going to be a situation where you're going to say, man, if I had more time, I can do it. Okay. This midterm that I gave last year turned out to be way too long, right? I timed myself and I said, well, how long did it take me to complete? And I kind of, gave a multiplicative factor and said, okay, well, maybe it's fine for the students. I not forgot, but it's like, because this is your first course on Python, like, you're even slower than I had imagined. So, so it's fine. So I just have to make so I think last quarter I shortened it down, or in the fall quarter I shortened it down, and I'll try to shorten it down. So this one probably will take you like four hours or 5 hours. I don't know how long it's going to take. Okay, especially if you're new to all of this stuff, right? And if you're even like slower where you're looking stuff up, you'll be even worse. So, a few things to kind of prepare is, just try it, and then right away you're going to get stuck and you'll be like, how do I do this, right? Every function, every method that you use, write down on a piece of paper, okay? It's tempting to just go online and look up a Python pandas cheat sheet, NumPy cheat sheet. Those things are useful and those things are great, but if you want to if you force yourself to like write this thing down by hand on a piece of paper, it starts to process a little bit more in your brain, okay? So kind of work through this. I'll probably release the solutions for this thing like sometime next week, okay? So you can kind of compare how you've done. And, there's going to be multiple... like everything else, there's multiple ways to accomplish the same task, right? Like if I say summarize this thing, there's a bunch of ways to do it. And then yes, and I apologize for taking so long to get the homework written for pandas. But there will be a homework, and I'll make sure it's due after the midterm, but it'll probably also serve as good practice here, okay? Are there any questions? Yes?
Is the grading based on the code or just the results?
Grading will be based on the results, okay? Your code has to have run. But yeah, like if somebody did it this way and you did it this way, but you get the same results, that's fine, okay? Like if I ask, I don't know what this. Oh, so this is like on body measurements, and we're looking at like how much do babies weigh and stuff like that. And if I said, what's the average weight of a boy and what's the average weight of a girl or something, like that number should match mine. Okay, according to the data, our numbers should match. So you can try through this, and the questions are presented kind of like this. So here is this is what they did last year. Okay, so I said baby weights. Do baby boys weigh more than baby girls on average? And you go through the data, and calculate and display the mean weight of baby boys for each month from month 0 to 12. You'll produce 13 values, one for each month, right? So, see, because this was data that they've collected. They have a 2-month-old baby boy, and they weighed it, and they did this for a bunch of people, and they said, and I'm asking, what's the average for a 2-month-old baby? All right, is that okay? Really, force yourself to use Python and pandas. Okay, that's the way you're gonna get better. Okay, yeah.
You said the midterm is 2 hours and it's take home. How are you going to do that?
So don't come to class next Friday. Okay, next Friday we're not gonna meet here. Make sure you are somewhere that is connected to the internet. Okay, so at 2:50, whatever, make sure you're in a quiet place somewhere, you go to the library, I don't know, wherever, right? And then I'm going to post the file online at 2:59, okay? And then it will be due at 5 p.m., okay? So you'll download it at 3 o'clock, you'll look at it, and then you'll start working, okay? And then you'll put in all of your answers, and then you'll save as HTML or PDF or something, and then you'll upload your answers on CCLE. Okay, so that will just be done at home. Nobody told me that they have a conflict next week from 3 to 5 p.m. I don't think. Maybe. Send me another email if because I don't remember anybody talking to me about this. Okay. Yes, question.
Just to verify about these, the internet and
Yes, absolutely. It's open internet. It's just not open talking to friends. Okay. So the only restriction is you cannot talk to other students. Okay, or I should just say other people. You can't talk to anyone. Okay, but you can go online and you can look up which function you need to use with Python pandas. Which you can look at all of the past notebooks and stuff like that. That's all available. Okay, it's a kind of just. It's not so much a memorization thing. It's more so can you accomplish this in a constrained time? So the biggest issue I think is going to be speed for everybody. Okay, that seems to be the biggest issue where if you're slow or right now probably you don't know how to do how things should be done, but you don't know the vocabulary, you don't know the words. And so there's a lot of time spent up looking Python pandas how to do this, right? And basically, I'm hoping between now and next week, you're going to spend some time practicing so you don't have to constantly be Googling every single one of these things, okay? Because if you're in that situation where, okay, because if I ask you to do this in R, you probably have an idea of how to do this, right? Display, find the mean weight of baby boys for each month from 0 to 12. What are you going to do? First, you've got to kind of filter down to boys, okay, baby boys with ages 0 through 12. So what are you going to do? So in Python, we would use .loc, okay, .loc, where and then we would specify the age of the boys is this, or sex is male and age is this. So we locate the values there, right? And then we need to calculate the mean for each month, right? So the next thing we would do is we would do a group by month, and then we would do a mean operation for the weight column, okay? So you do, probably you do it, and you can probably change this all in one line, but you would do a dot loc and select the observations. Then you would say we're working with the weight column, so you would do dot weight. I'm sorry, you would do you have to do the group by before that. So you do a dot group by. You group by the month, and you're looking at the weight column, so you do dot weight, and then you're asking for the mean, so you do dot mean. Okay. But so I think you guys know kind of what needs to be done, but probably you're not accustomed to this. So just kind of practice and write down everything you have to look up, write down on a piece of paper, and then you can glance at the piece of paper, and that's quicker than typing it into Google, right? Or typing into your search engine and searching. But yes, the internet is an open resource. You're just not allowed to post your question in the Stack Exchange. I don't think you would get a response within 2 hours anyway. And then you can't message your other friends, and that's on the honor code. I don't have a way to truly enforce that, okay? Because I'm not gonna visit your house while you're taking the test. But we're gonna be on an honor system there in terms of not talking to each other. And I think everybody will feel the time pressure that to be talking to other people is gonna be you don't want to be burdened with other people's stuff. So that's kind of gonna be how it is, okay? And then I'll release the answers to last year's midterm sometime next week as well, and they're probably Tuesday or something. Okay, is that all right? Okay, so today we'll look at a little bit more matplotlib stuff. I'll also talk about a package called Seaboard. Seaboard does some nice stuff, okay? All right, so anyway, this is just real basic stuff. This is going to be mostly for reference, but I'll just kind of mention these things along the way. So we saw with matplotlib, you can just kind of call plot, and every time you call plot or you have it do something, it's going to just keep adding to the plot until you call show, plot show, plt.show, and then it will finally release this, right? So here I just said, give me the numbers. Lin space will go from 0 to 10. I want 1,000 entries. And then we're going to plot basically 3 lines, x versus x versus x plus 1, x versus x plus 2. So I just have these diagonal lines. And then the color is going to be blue, green, and red. All right? So ta-da, there you go. All right, so 0 through 10, blue, and then one unit above that, and 1 unit above that is blue, green, red. And then you kind of have, this is just your basic colors. So as far as colors go, you can use single letter abbreviations, okay? And then I think I already showed you the list of named colors where it includes things like the, what was it, antique white and, blanched almond, which I guess are colors that you can name, okay? A few other things. These are just mostly stylistic things, but Pandas also has kind of the works with matplotlib, and will produce these plots. And so if you want different line types, okay, you use line style, and you the default is solid, okay, but if you do dash dash, you'll get a dash line. Dash dot will create a dash dot line, and then colon will be dotted, okay? And so so you can take a look at what this looks like. And by default, when you call multiple instances of plot, matplotlib defaults to using different colors, okay? And you can override that and say, I want the same color for every single one of these, okay? But this is the solid, this is the dot dashed, this is the dash dot, and this is the dotted, okay? All right, so what is this gonna do? I've got X, I've got 100, I did random.random. What's that gonna make? This is random uniform. This is how NumPy does random uniform numbers. So I'm gonna get 100 values from 0 to 1, and 100 of these things, and we're going to just create a scatter plot, okay, from 0 to 1, and so this is just uniform random, okay? This is pure uniform random, follows a Poisson process, things like that, right? You know, and if you create a grid and you ask how many dots are within here, it follows a Poisson count, right? Okay. You can call, you can specify things so that when, so here I'm just going to take random integers from 0 to 10 and multiply it by 100. Okay, so this is going to be random values of 0, 100, 200, 300, up to 900, but you know, randomized. And then for color, I'm going to use values 0, 1, 2, 3, or 4. Okay, and so we can just kind of see, and you can see, you know, I've got 900 and 0 and 600 and stuff like that, and then just random values of 0, 1, 2, 3, 4. And then so for 0, 1, 2, 3, 4, I'm going to associate it with an array of colors. So if it's 0, it'll be red. If it's 1, it'll be blue. 2 is green, and things like that. So you can imagine, like, here you can imagine now I'm kind of building up a data frame where I've got column X coordinate, column Y coordinate, column for size, and column for color, or something like that, okay? These are just random values, but I'm just creating these arrays here, okay? And so here we will subset, okay? We'll use square bracketing to subset this colors array using this vector, right? And so the first sequence goes 2, 0, 1, 4. So we're going to get green, red, blue, yellow, right? So because green is 2, red is 0, blue is 1, and yellow is 4. And that's going to be our first 4 values here, 2, 0, 1, 4. So if I do that, indeed I get green, red, blue, yellow, and we can see that this now corresponds to this. And now I can use this to kind of draw my scatter plot. So these are just the 2-dimensional random uniform values. And now I'm going to draw the exact same plot, but I'm going to replace all the dots with different colors, okay? And then I'm going to also alter the size. Well, actually here, let me just change the different colors, okay? And so this is the same, like this corner here with this triangle, you know, appears right here as well, okay? So, you know, it's the same dots, same pattern. Maybe I should have used the same figure size and you would see, you know, that it is indeed the same, but I've just changed the color of the points. But I'm going to go back to the big size, okay? And then you can also alter the size of the points doing S is equal to Z, and then so now some of the points are big and some of the points are small, okay? And then alpha equal to 0.4 modifies transparency, all right? So you can kind of map the size and the color to different values inside the you know, some kind of vector of values, okay? So that can be done. It's not, it's a little bit different from ggplot, okay? And you know, I'm biased and I think ggplot's probably the best. But ggplot, you can just take some kind of variable and do an aesthetic mapping between the variable and the attribute, and ggplot will figure out how many colors it needs to assign, you know, what sizes and what range and all of that stuff. Okay, matplotlib is not as smart. You're going to have to take, you know, one of the variables and convert it into color values. You're going to have to say, you know, just like we did, you know, in ggplot, I could have said, you know, take this thing, 0, 1, 2, 4, and just map it to the aesthetic of color, okay? With matplotlib, we've got to kind of manually kind of specify kind of the color mappings using something like this, okay? It's not as kind of automated and stuff, all right? You can also change the point markers, okay? And this is, I think, I showed you a web page already, and we already looked at like the hexagons and stuff like that. And so here, I'm going to just plot, the first 10 with stars, and then I'm going to plot the next 10 with O's. I think O is the circle, okay, with circle. And we're going to just label these Group A and Group B. And now I've got, red stars and blue circles labeled as Group A and Group B, okay? And so these are just, some of these things. Suddenly this feels very patriotic, huh? And so, this is kind of what we've got here, okay? And I think we've talked subplots already, so again, so here, what will subplot 2, 3 do? It's going to create 2 rows and 3 columns. So it's going to create a 2x3 grid of 6. And we're going to say starting from 1 and going up to 6, range 1, 7. Right? And so this is a little bit of a weird thing. Everything else in Python is 0 indexed, but the subplots are 1 indexed, right? So subplot 1 is the top left, and it goes horizontally. So it's going to go 1, 2, 3 on the top row, and then 4, 5, 6 on the second row. And so, so all I'm doing here is I'm just gonna, we just asked it to make a grid of plots 2x3, and then as far as what it's plotting is just gonna be plotting text, at the location 0.5, 0.5, and the plot, it's gonna be just the text plot plus the string 2, 3, I. So it's not, all it's doing is this, okay? So this is, subplot 231, subplot 232, subplot 233, and it just kind of shows, how do you access this one? You tell it you want to deal with subplot 2, 3, 6 to indicate the 6th in this subplot, which is arranged in a 2x3 grid. And so this is almost, I'm just gonna hit enter here, but basically you can specify, you could imagine creating a complicated plot, okay? All right, and so here I'm doing grid spec 2, 3, all right, and this is annoying, but you can kind of, so I've got a 2x3 grid, which is kind of like this, okay? But you can have it specify, and so you can say, so this, and this is like the worst. So subplots are 1 indexed, and it goes 1, 2, 3, 4, 5, 6, but then when you use grid spec, it's 0 indexed, and so the top left is going to be grid 0, 0, okay? And then, and so here is, so grid 0, 0, I'm going to draw a scatter plot, okay? And then here, I'm going to create a subplot using grid 0, 1, 3, all right? So 1, 3, if I slice the integers with 1, 3, what values am I actually getting? I'm just getting 1 and 2, right? And so, so what this will do is it's going to look at row 0 and plots 1 and 2, which will be this one and this one, and it's going to create a plot, one plot for these two kind of regions, okay? And then over here I'm doing row 1, okay, which is down here, and it says :2, which is going to give me these two, and then the last one will be this one over here, okay? And so you can take the take a kind of the subplot, a grid specification where you say I want a 2x3 grid, and you can say I want to draw something in this one. I want the next plot to kind of span 2 spaces. I want the next plot to span 2 spaces, and I want a plot to be in this kind of third corner. All right. So it's possible to do stuff like this. As you can see, it's a pain though, okay? All right, it can be done. It's a bit annoying, okay? But when you're into something and you really want to get something to look the way you want to do it, you can do it like this, okay? I'm not going to make you do stuff like this on the midterm or anything like that, okay? So don't worry about it, but just so you know that this feature exists, okay? And then, all right, so I didn't even write this code, okay? I just copied it from someone else, which does basically this, basically does something like this to create a plot that we want, okay? So basically the idea is I've got this two-dimensional multivariate normal data, right? So this is what this is. I'm using the multivariate normal to generate 3,000 random points using this mean and this covariance matrix, okay? And I'm going to create a grid spec that's 4 by 4, and all of this says is basically in one of these areas I'm going to create the scatter plot, and then and I'm going to have one of the sides I'm going to create a histogram, on another side I'm going to create another histogram where it's the orientation is vertical and horizontal and stuff like that, okay? So, you know, you can look at all of this code, which is, you know, a bit of a pain to create, but ta-da, here's your multivariate normal, and it shows that, you know, when you, like, I don't know, if you imagine you've got the board with the multivariate normal, and it's like chunks of, I don't know, marbles or something, and then you lean it up so all the marbles drop, you know, they form like this, and then if you lay it flat and you turn it this way, you know, when you project it in the other direction, it also forms a normal distribution. So the multivariate normal, you know, when you project it just down onto one axis or the other, are normal distributions themselves, which we can see here, but there's also correlation between the two, so that's why we get this ellipse-looking thing, okay? Again, you know, who wants to type this, right? You can do it, but it's also, it's like in R using base graphics and messing around with par, mfrow, and then trying to do all of these things and adding legends and all that. It's annoying, right? That's why we like ggplot and stuff. Okay, histograms, we can make histograms. I think you can add options. So you can change like the number of bins. You can change the color, which is the fill color, and edge color, which is the line, right? It's just, so this looks kind of pretty, I think, okay? And then you can also change it to a step-filled histogram, which doesn't draw the individual lines between them, but kind of just creates, I don't know, some polygon shape, okay? Different choices, okay? And we use bins for histogram. Okay, here is, here's a nice little thing. I don't think we've ever talked about kwargs, okay? What is a kwarg? Kwarg stands for keyword argument, okay? And so this is a way so over here, right, I specified histogram, data, bins, alpha, hist type, color, edge color, right? So here I can say, you know what I want? I've got 3 different random normal distributions. I've got 10,000 values where it's centered at 0 with standard deviation 0.8. I've got 10,000 values where it's centered at -2 with standard deviation 1. I've got 10,000 values where it's centered at 3 with standard deviation 2, okay? And for each of these things, I'm going to say I want a histogram, okay? But we're going to call kwargs, which says I can specify the kwargs here, which is going to be a dictionary of basically all of the attributes I want. Histogram is step-filled, alpha being kind of the transparency is 0.2, density is true, bins 40, edge color is black, okay? And rather than having to copy and paste PLT histogram each time with all of the same arguments, I can just specify ** kwargs, and it's going to fill in all of those different arguments for each of these things. Okay, so when I run that, I get kind of our 3 different normal distributions plotted here. And then if I wanted to, I can get rid of, some of these arguments, keyword arguments. I can do that. And so that's no longer going to be step filled, but now we'll have kind of, the vertical, the boundaries of the bins and stuff. And we recognize, okay, maybe that makes it a little bit harder to read, okay? And so you can do this, and you can specify, the transparency levels and stuff like that. And if you wanted to, you can change the color here. What was that called? Almond? Oh no, I get it wrong. Rose. Nope. I don't know. Okay, red. Red works. But it has its own colors and stuff. I don't remember. What are the matplotlib color names, right? We've got Dodger blue, which will look a lot like other blues, but there you go. Okay, so you can do all of this, and it kind of has its default behaviors as well, and stuff. Okay, so I think this is a nice thing where a lot of times you want to create like multiple plots with the same kind of arguments for each of these things, and you can just create kind of a dictionary of all of the values, and then you insert the dictionary into the command for the plot. Two-dimensional histograms for multivariate normal. So this comes with histogram 2D. Okay, and then we can add color bars, which was kind of like a legend, and it looks like this. So this is a two-dimensional histogram, and like another option is the hex bin histogram, which looks the same except instead of squares, you have little hexagons, and it's basically just showing us the exact kind of basically this thing, right? Showing that, but now. I don't know. This kind of looks like that black hole photo, right? Well, maybe not. The black hole photo is really impressive, actually. This is just like some blurry image. Okay. But there you have that. Okay. We have something called Seaboard. Okay. It kind of depends on matplotlib and NumPy and stuff. But the convention is to import Seaborn as SNS, okay? And here's an important thing. Seaborn is for visual exploration, okay? And Seaborn is kind of like, it's almost like a handbook of just like useful, I don't know, ready to go recipes, okay? And so it's got a handful of these things. And so one of them is the distribution plot, the dist plot. And it's kind of like a histogram, along with a smoothed out kernel density estimate thing. Okay, so here I got some random normal data. And when you do this, it creates a histogram with a density curve on top of it. Okay, and then you have options. You can turn off, you can say I don't want the kernel density thing. You can do KDE is false. You can change the number of bins in the distribution plot. You can add what's called a rug, where it gives a little indications of the individual data points themselves. Okay, and so here's that. Okay, here you can turn off the histogram, add the rug back in. So this will keep the kernel density estimate and stuff, and you have different options, right? And as far as the stuff goes, if you want to change the bandwidth of the kernel density estimate, you have to call KDE plot directly, and you can mess with that as well. Okay. So these are just options. Remember all of that stuff we had to type in for this thing. Okay. Look at all this mess of code. All right. Seaborn makes our life super easy, all right? It's just one line. okay? Well, here's our data, okay? Just one line, joint plot, okay? Oh gosh, this is so much easier and better and nicer, okay? And it creates this scatter plot, and it creates kind of histograms on each side, okay? It's so this is really nice, right? And if you can also change the option to be, you know, if you don't want the histogram but you want KDE, kernel density estimates, where it kind of creates these contour lines, it's way easier, right? So this conveys pretty much the same information as this thing back here, but instead of however many painful lines we had to write there, it's one line, joint plot, okay? And so, you know, just like everything else, you can always search online and say, you know, Seaboard examples. All right, and so this is these are just different examples, and you can be like, oh yeah, that looks cool, right? And then, you know, it'll basically have kind of the there's a little bit more lines of stuff that we want to write, but it looks like wait, no, that's the facet grid. So you'd run a facet grid, and then it looks like you just kind of add some of these plots, the KDE plots. Okay. So, you know, different examples here. The good old iris data, it'll create kind of, you can have it create pair plots, okay, which will create like one variable versus the other, and also create kind of histograms down the side. I think, you know, you have something similar in R called pairs, okay? You also have the option within Seaboard, you can do something similar to ggplot, where you map a category to a property. And so in Seaboard, it's called hue. It's not the color, it's the hue. It's a little annoying that everybody has different keywords and stuff, okay? And I forget everything, okay? Don't feel bad. But you can map one of the species to, say, the color, and then and suddenly this plot is like super enriching, right? Now you can see like the setosa and the virginica and the versicolor, and really see kind of the different clusters and patterns and stuff that appears, okay? And this is, like, for one line of code, this is an impressive plot, okay? So Seaboard does a lot of kind of this behind the scenes stuff. It really only has a few, I don't want to say a few, but there's really only kind of specific things and that are intended to be used a certain way for visual exploration, okay? Once you start going beyond and you want to like customize something, Seaboard's probably not the way to go, all right? But it's quite useful for visual exploration, okay? There's a tips data set, which looks kind of like this. And, you know, they said, you know, I don't know when this data was created, right? The total bill for a party of 4 people was $25. I don't know where you can get dinner for 4 people where your total bill is 25 bucks, okay? But anyway, this is, that was a Sunday dinner, okay? So it must be old data, right? And you can create plots. Now Seaboard has all of these funny names for everything, right? So strip plot's kind of like this dot plot thing. You can add a jitter, so they're not all stacked on top of each other, and this gives you a little bit of density relationships. By default, it chooses to have different colorings here. A swarm plot looks kind of like this, except they're not laid on top of each other, but they, I don't know, they kind of form some structure like this. This is called a swarm plot. This is, you can map the a different attribute like sex to the color, and so now you have for orange and you have it for blue for female and male based on whatever. And so this is the same thing, but now colored based on the sex. You can do something like the day, okay, and there's going to be 7 days, and so there's going to be 7 different colors plotted here, and it's like, it's too much information that it hurts your brain to look at, right? Like this is like, I'm sorry, 4 different days, okay, and we took sex and split it here, male, female, but it's now we have to identify which ones are Sunday and which one's Thursday and Friday and Saturday. It's this is like terrible, right? This is easier to interpret than this. This is a disaster, okay? But there's kind of an aspect of mapping, you know, one of the attributes in the data to a visual property here, okay? You can do box plots, okay? You can turn them sideways. You can also, you know, map the sex to one of the hues, okay, and split this. And this is, I think, you can play around with this, you know, for your EDA sections of your reports. I think this is, you know, a simple way to kind of just get through for some of these things. There's something called a violin plot, and you can look up, there's a XKCD comic about violin plots, and it's kind of funny, right? Just commenting about the shape of the violin plots, which I guess it looks like a violin. It also looks a little weird. Okay, so they're like histograms or like kernel density things, but split on these things to go. Okay. There is you can do a facet grid. I think this is one of the really nice things. This is something you can also do with ggplot, the facet grids. But basically, you can create a grid based on something like sex. Okay, so we're going to create a facet grid for this data, tips, based on sex. Okay, and so we're going to have basically 2 separate graphs, one for male and one for female. And then you use something called you map the facet grid. So you define the facet grid as kind of G, the grid, and you map onto the grid, you're calling distribution plot, right? So distribution plot's the thing that creates the histogram along with the kernel density estimate, and this will do it. And because the facet grid created one for male and one for females, this is now the distribution plot for the males and distribution plot for the females, which is quite nice. Okay. And here, facet grid for day, so we're going to have four of these things, one for Thursday, one for Friday, one for Saturday, and one for Sunday. And we can just, you know, map. So this one uses a matplotlib histogram thing, and we can map that to the thing, and it creates matplotlib histograms. Oh, and the key here is I said map the columns of the facet grid to sex, and here I said map the rows of the facet grid to day. Okay, so here is, you know, day is Thursday, day is Friday, day is Saturday, day is Sunday. Okay, and now you can like even do, you can have a facet grid for row and a facet grid for columns. So we're going to map the time of day to the row and the sex, male or female, to the columns, and then again you map a plotting command onto the grid itself. Okay, and so here we'll have kind of things for males at lunchtime, females at lunchtime, males at dinner, and females at dinner, right? And so these are kind of the histograms for all of these things. So I think that's kind of a neat thing. Count plots are basically bar charts, but Seaboard calls them count plots, okay? And you get something like this. And again, you can map something like hue to lunch or like the time lunch or dinner, okay? Oh man, we're gonna run out of time because there's a whole nother thing I wanted to talk about called stats models, but you can also do basic linear model fits, linear regression things, okay? But again, this is one thing to note is that for Seaboard, it's just for visualization and exploration. It's not for actual fitting a linear model. So Seaboard actually doesn't even give you a way to calculate stuff like the coefficient, like the slope and intercept, or the r-squared, okay? It just draws a line, okay? It's just for visual exploration. So here I can do LM plot, and it draws this, okay? But there's no way to figure out from Seaboard what's the slope, what's the intercept, what's the r-squared, or any of that information, okay? So here I just have x is bill and y is tip, and there's a positive correlation here, okay? You can do stuff like I want a low S curve, okay, which looks like that, okay? Here's a plot of the residuals. It allows you to figure out the residuals, but that's about it, okay? And a handy thing is you can map something like smoker or one other variable to the color or the hue of the dots, okay? And it fits separate lines for each of these things, okay? Which is nice, okay? So this is, again, it's just for visual exploration, and this to us indicates that, oh, maybe it's worth exploring the linear model between a linear relationship between bill and tip for smokers and bill and tip for non-smokers separately, right? Because maybe the slopes are different. It sure looks that way, and we could explore that in the actual thing, and not just but as far as visual exploration goes, this is all we have, right? You can do something similar with the facet grid as well, okay? Oh man, okay. This is just going to be a super simple example using something called stats models, okay? So I know you guys are here to learn Python. My biased opinion is that for basic stats modeling, R is easier, okay? But Python can do it, okay? You've got to import something called stats models, okay? And there's the stats models API and the stats models formula API. I guess I'll have to cover this next week. And this could be something that's going to be useful for your final project, okay? I'm not going to be testing you on stuff like stats models in the midterm exams. The midterm exam will cover pandas and some basic visualization stuff. And I think the practice midterm gives a good sense of the kinds of stuff that you'll have. So again, this weekend, really start to force yourself to use Python for any kind of data exploration. Try to work through the exercises in the midterm. And then I will post a homework. I'm sorry for the delay on that. Yes, question?
What's the average?
What's the average for what?
Last year's midterm.
I don't remember. It was low because I made it too long. So I think I ended up doing some adjustment to bring up the class average. I do my best to write a fair exam, okay? And if the median of the exam is significantly lower than 80, I'll usually just kind of add points straight across the board, okay? I'm very much against curving, where it's like this top 30% gets this, and the next 30% gets this, and the 40% gets something else. I'm not into that, okay? But if there does need to be just some kind of overall adjustment made, I can do that. But that's as far as I go for something like that.